So here in this problem, we need to find out the sum to n terms of the following series. Let us begin. So here we have a series with first term being 2, added to the next term, which is 5, followed by 10, then we have 17, and then we have 26, and the rest of the terms. Now clearly, this is not an arithmetic series because it does not have any common difference. Also, it's not a geometric series, for it does not have any common ratio. But we can observe a pattern here. If we take the second term, which is 5, and from here subtract the first term, that's 2, this is going to give us 3. Then we take the third term of the series, which is 10, and from here subtract the second term, the 10 minus 5, that gives us 5. Next, we take the fourth term, that is 17, and from here subtract the third term, that's 10, that's going to give us 7. Then we have 26 minus 17, so that's going to give us 9. Now clearly, we observe here that 3, 5, 7, 9, these terms are in arithmetic progression, with the first term being a and the common difference being 2. First term a equals to 3 and the common difference equals to 2. Now, this is known as the method of difference. So, we'll be using this method to find out the sum to n terms. For this, let us suppose that Sn represents the sum up to n terms, where the nth term of the series is given by Tn. And if Tn represents the nth term, then its previous term will be Tn minus 1. Okay, now what we'll do? We'll again consider the same sum as n. So, we have 2 plus 5 plus 10 plus 17 all the way up to Tn minus 1 added to Tn. Okay, so here we are going to perform a subtraction. Now, on the left hand side, we have Sn minus Sn, so that's simply going to be 0. What we'll do, we'll exclude the first term of the first series Sn. Let's keep it as it is, as 2. Next, what we'll do, we'll do 5 minus 2, so that gives us 3. Next, we have 10 minus 5, that's 5. Added to 17 minus 10, so that's 7, added to 26 minus 17, so that's 9. This goes all the way up to here. If we consider the third last term, so that's Tn minus 2. So our subtraction will be simply Tn minus 1 minus Tn minus 2. Then we have added to it Tn minus Tn minus 1, and then we have negative Tn. We'll transpose this negative Tn to the left hand side, and this is going to become Tn. This will be equals to 2 added to. Now from the second term onwards, all the way up to the second last term, what we have here is a arithmetic series with first term being 3 and the common difference being d. We know that the sum to n terms of any arithmetic series, that's defined as n over 2 multiplied to 2 times the first term added to the total number of terms minus 1 times the common difference d. Now, what is the total number of terms of this arithmetic series? So there are in total of n minus 1 number of terms and not n number of terms. The reasoning is this: while considering the first Sn, we excluded the first term 2 and we included only the second term all the way up to the last term. Now, since Sn by definition has got n number of terms, the moment we exclude one of the term, it's going to be left with now only n minus 1 number of terms. Now, the same thing is also happening to the second series Sn. So here we consider the second term all the way up to the second last term, and here we excluded the last term Tn. So that means the second series has also got n minus 1 terms. Now we subtracted one n minus 1 terms from the other n minus 1 terms, and that's going to leave us with n minus 1. So let's now find out the sum. So our sum is going to be the total number of terms, which is n minus 1 divided by 2. This is going to get multiplied to 2 times the first term. So that our first term being 3, so 2 times 3, that's going to be 6. Added to, we have n minus 1 minus 1, that simply becomes n minus 2. Multiplied to the common difference, which is going to be 2. So when we simplify this, we're going to get n squared plus 1. Now that we have the nth term of the series, we can easily find out the sum up to the n terms, which is defined as the summation of the kth term, where k is an index that runs from 1 to n. Okay, now we have summation of k squared plus 1 with k running from 1 to n. So this can be also expressed as summation of k squared with k going from 1 to n added to summation of 1 with key running from 1 to n. Now what is summation of k squared? Summation of k squared, that's simply the sum of the squares of the first n natural numbers. Now that means this can be expressed as n times n plus 1 multiplied to 2n plus 1 whole divided by 6. And then we have summation of 1, so that's actually 1 added to itself up to n number of terms, to n terms. Or in other words, we can say this is simply 1 multiplied to n, or which is equals to n. Now let's use this value. So now we have n square n times n plus 1 multiplied to 2n plus 1 whole divided by 6 added to n. When we combine this, let's take n over 6 as the common factor. So that means we have n plus 1 times 2n plus 1. So that's going to give us 2n squared plus 3n plus 1 added to 6. And then finally, this gives us n over 6 multiplied to 2n squared plus 3n plus 7, which is going to be the sum to n terms of the given series.